Hello, welcome to the Openshift Service Mesh demonstration. I've just run a clean instance of Openshift up on my laptop as a CRC deployment. If we copy the admin password, we can go to the Openshift console and log in as admin. And we've got a nice clean Openshift. So the first thing we need to do is install a couple of operators. So to run the service mesh, we'll need 4 operators. We'll need the Elasticsearch operator, which is where we're going to store traceability data. We'll need the Jaeger operator. Make sure we pick the Red Hat version. We'll need the Kiali operator, which is our observability applications, what we're going to use to look at the service mesh. Pick the Red Hat one. And finally, we need the service mesh itself. That one there. And that will then download and install those operators. So we've just waited a moment and we've a few minutes and we finished installing those operators. So what we need to do now is we need to actually create a service mesh control plane. So to do that, we create a project called Istio System. And then we go to the installed operators, we go to the service mesh, not that one, the service mesh. And the first thing we need to do is to give the projects that we're going to actually run up our applications in access to the service mesh. So we create a member role, we just edit that member role. Quickest way is to edit the YAML. We'll add a project called a test1 because that's the simplest, nice simple project name, and it appears at the top of the list of alphabetical project names, quick to select. So we save that. And then the next thing we need to do is we need to actually install a control plane. So we'll just accept all the defaults for now for the purposes of a simple demonstration. And if we now go to switch to the developer view to look at the project, we don't need the tour. So if we look at the project, we'll see that the Openshift service mesh control plane is running up a whole load of things based on the operators that we installed. So we've just waited a few minutes for the control plane to deploy itself, and we can look at the project there and we'll find that it's created some routes for us as well. So these are the monitoring tools: Grafana, Jaeger for traceability, Prometheus for monitoring, and we're waiting for the final one, Kiali, to start, which will be our observability. That's going to give us a graphical view of all the services that are in our service mesh. So we just need to wait a few moments for that to start. Okay, so I can't see Kiali there. Where is Kiali there? We definitely installed Kiali as an operator. So this is showing us our service view, and there's Kiali. Kiali's just started. So if we go to our project now, if we go to our routes, it's just finishing off, starting those bits. And we've got an extra route now. So we've got our Kiali, which is going to be our observability and monitoring our service mesh. So if we go to the services that is created, let's have a look at that. So Grafana, fairly basic. It's got a service mesh SDOD. It's got an egress gateway service, a ingress gateway service. It's got a Jaeger agent. It's got a Jaeger collector, which is important to us. So we're going to need that IP address. You'll see why in a moment. It's got a Jaeger query, a Kiali, a Prometheus, and a Zipkin collector. So if we look at some deployments, what we've got here is we're going to deploy 4 applications: a deployment A, a deployment B, a deployment C, and a deployment D. So they're all fairly similar. First of all, let's have a look at Service A. So Service A has a deployment. As part of that deployment, we've added an annotation saying that we'd like a sidecar for it. So in a service mesh, sidecars talk to sidecars, and sidecars talk to applications. Applications never talk to applications directly. They always go through their sidecar. So we've got a simple fake service here that I got off of Console's Docker Hub, and we can give it, it'll output a message, and we can give it some values here to tell it to distribute its timing to make the traceability a little bit more interesting. And finally, it will be broadcasting traceability metrics on this Zipkin port here. So this needs to go to our Jaeger collector. So if we save that, and we need to do the same for service B, an OCP 10 dot internal IP address, and we'll leave C so that it goes to one that doesn't exist, because that will create some interesting tracing. And then we've got this deployment D. So deployment D is a simple curl service that we're going to use to call an external system. And then we have these 2 gateways. So first of all, we've got an ingress gateway. So an ingress gateway is for traffic that's coming in. We define a gateway, and we say that it's HTTP just for the simple purposes of a demonstration. In a real service, that would be an HTTPS, a TLS gateway. And we say that we're going to look for, this gateway is going to accept traffic on these 3 hosts. So in my etc host file, I create IP addresses to my OpenShift cluster corresponding to each of those hosts, just to fake the DNS. And then we've got this virtual service to route the traffic. So anything that comes in on this host is going to come to this gateway, and then this gateway, this ingress gateway, is going to, this virtual service is going to wrap this ingress gateway, and this ingress gateway is going to look for these hosts, and then it's going to match the request based on the HTTP host header. And then depending on what that host header is, it's going to send it to a particular service inside the mesh. So the idea here is that we route to the cluster by IP address, single IP address, multiple hosts, and then we route to the final host destination by header. So this is HTTP header. The idea is in a real service mesh, this will be an SNI header, and we wouldn't have to terminate the TLS. It would just be passed through to the final host that would terminate the TLS for maximum performance. And then we've got an egress gateway. The egress gateway is just going to demonstrate calling a service external to the service mesh. So we've just got a little taken from the Istio demo. We've got an external service CNN news feed, and that's going to be import 80. We're going to have a gateway again. This gateway is going to accept traffic on this host. So remember, this is external traffic this time. We've got a rule just to route the traffic, and finally we've got a virtual service again to wrap the host and send it to the final destination. And then what we've got is we've got a little deployment file here, which is a little shell script. It's going to run a mixture of Cube CTL files and Openshift commands. And the reason for this is that the Cube CTL commands work with the Istio gateway, which is a Kubernetes product, and the Openshift command is going to be used to create the routes and the deployments. So the idea is we clean up all the gateway features, all the service mesh features. We clean up all the routes and services. There won't be any there because it's a clean project at the moment. And then we deploy our 4 deployments and then our 2 gateways, ingress gateway and egress gateway. So we can log into the project as a developer. And we can create a new project. And we can run our quick deployment script. If we go back to so we're in project test 1 this time, and we'll see that we're running up all this stuff. We've got 4 deployments, and we'll end up with 4 services and 4 routes eventually. So we've got 4 services, run up okay. And we've got 3 routes. So we're only actually going to have 3 routes because our last service didn't have a route on it. Our last deployment didn't have a route on it. So we can look at each of these services, and they're just going to return a name, a message, some simple stats, service B, service C. Okay, so what we can do now is if we go back to the Istio project and we look at the routes there. So the first thing that we'll do is we'll look at the Kiali dashboard. So we can log on to this with the Openshift admin password. Okay, so if we look at the services, in the namespace, in the Istio namespace, we've got that. So we should have some projects in the A1 namespace as well. Let's have a look at the Istio config. So I think that's still starting. So we might need to wait a moment or two for that to start. Okay, so we just waited a few minutes and everything's come up now. So if we look at our graph, you can see we've got a sidecar for service A, and that calls service A. We've got a sidecar for service B. We've got a sidecar for service C. That calls service C. Now we've got this pass-through cluster, and that is because we didn't put the correct Zipkin Jaeger collector in for service C. So we did that deliberately, and you can see that it's already realized that there's, in terms of the mesh, there's a problem here. There's no destination for that. So what we can do now is we can Just make sure that we've evaluated this. So what we're going to do is we're going to run some curl commands inside the Kubernetes node. And we've got this simple little Perl script, which is going to call to the external service. So that's working there, okay. So let's just go to this route. So we created an OpenShift route around this service. So we can curl this service. So that's using the OpenShift route, but we can also access it via the ingress gateway. So let's do that. So, and that ultimately goes to the same service. So the top one is via the OpenShift route, the bottom one is via the ingress gateway. So what we can do now is we can actually delete the OpenShift route. Let's delete that. Delete route. And we can do that curl again. And this time it's not there because we've deleted the route. There's no OpenShift route anymore, but there is still an ingress gateway. So that's working as before. So we're not actually using the OpenShift routes. So we have this, we can run this little Perl script, which will create load into the cluster, calling service A, service B, service C, service D, which goes to the external to the CNN. And then we can go to our Kiali, and if this is being generated in real time, so this is based on real traffic. So if we look at the applications and the services, so we can look at both. If we look at both namespaces, the Istio system, the service mesh control plane, we can see a little bit more. So we've got this external service, the egress gateway calling out to the external service, and we should be able to see some traffic now. So let's just go back to just the service. So if we look at service A, okay, so we had a little bug in our load Perl script with the getting all the threads started. So I've fixed that now. So if we look at our graph of our system, it's going to plot out the system in based on the live traffic. So you can see that we've got service A going to service A, service B sidecar going to service B is going to the Jaeger collector, service C doesn't have a Jaeger collector because we deliberately put that in wrong. Service D is going to the egress gateway and to the egress gateway, and then finally to the egress gateway. So let's look at the workloads. We can look at service A, and we can look at the traces on that, not that one. Okay. Okay, so let's look at this again. So if we look at the graph is plotted in real time based on traffic. So we're randomly firing requests through the system to the different services. You can see that we've got an error here because we didn't put the Jaeger collector in correctly. So we should be able to look at the traces on that, and you can see that lots of them are errors. So if we want to look at that one, we can either view it on the graph, or we can look at the traces, or we can pick one that we think is problematic, and we can view it in our tracing application. So we can log into our Jaeger, which is our traceability application, and we'll need the Kubernetes, the OpenShift admin password for that. So kubeadmin and the password. Just accept the permissions there. And these are the metrics that we exported, or we're trying to export. So we see we've got an error, the traceability, and it gives us various bits of information, where it's coming through from, where it's going to. So we could look at, if we go back to the graph, if we look at one that's working, okay. Let's look at this one. Look at the traces there. We can pick that one. That one's particularly slow. So we look at the traceability of that. And you see that we've got a span here because we're going across a couple of different components in the mesh. So first of all, we are going to the gateway, and we've got a 301 to redirect it to the external service, which is on the internet. So that shows you a nice bit of traceability. And if the service, if all the different services meshes were used in the same Jaeger collector, then we'd be able to plot the traceability across all of them. And that's about it for now.